Hi, how you guys doing? Yes? Really? Much better, much better. All right, so first I want to start with community. I think Angular community is one of our best selling points. We have amazing people such as Dave organizing events such as lots and lots of different kinds of events all around the world. Turns out we don't actually run any of our own conferences that are out there are run by our community, which is very nice, and we really appreciate that. So thank you, Dave. I wonder how well there's a lot of different ways you can measure this particular number. Have up here is 30-day actives on our website. So these are the people who are reading our documentation, and we think that's a good proxy for how many people are actually using. So this is Angular 1 as of October 2015. This is as of May 2016. So we have grown quite a bit, even though we are now also growing Angular 2. So check this out. We also have quite a bit of growth on Angular 2. So put it together, we have in excess of 1.5 million developers at 30-day actives, which I think is a pretty good number. So the community is nice and healthy and growing. Now, you're wondering about why Angular 2? What have we done? So a long time ago in NGConf, a couple of years ago, we said we announced Angular 2, and we basically said we want to do it because we want to embrace the future of the web, which is the ES6, the lazy loading, faster change detection, and just kind of make it better. And over time, this kind of initial idea of making it a little better has grown into Angular 2, which started originally as a framework, and now it's really more of a platform. And so today I don't want to talk to you about all the things that you will get with Angular 2. So from framework to platform. So first, we totally revamped the dependency injection, the decorators, and then you have this thing called zones, which are the bee's knees. The cool thing about zones is that, all the times we have to call scope.$digest, zones make this unnecessary. We'll take care of the right kind of right change detection at the right time with the magic of zones. So that's cool. We have redone the compiler. One of the coolest things about the compiler, which we'll talk about more, is that we can do offline compilation. And offline compilation is important. I think I'm always in the view of this thing. Offline compilation is important because it allows us to get really small bytes to the browser, and it also allows us to be very fast. And we'll talk about that. We have redone the way change detection happens so that we can do we can provide more styles. So for example, if you like the React style, which is the data is pushed from the top to the bottom, and you have lots of immutable data set, you can use that with Angular as well. We have React storage mechanisms, so React Flux kind of a style ways of doing it as well. Or you can have the old way, or you can mix and match between the two throughout your application as well. And the next cool thing we have done is that we have disassociated ourselves from a DOM renderer. So we are no longer dependent on DOM. We can use DOM as rendering, and it's probably the most common way to render Angular application. But because we've dissociated ourselves from it, we can actually render native. We can render on a server. We can render across a web worker. And we can render into other platforms as well. So this is pretty cool stuff, which we'll talk about some more in a bit. The other thing we have done is now we've included Angular material. So this is the material design that the Google provides, is now included as part of the platform. We focused on mobile, which is how do I package up my application so that it is available and installed in a progressive web where you can navigate to a website and then slowly visit the website, and it will turn it into an icon that installs itself on your mobile desktop. And then when you go and visit the icon, make sure we have already pre-cached all the data so that even if you don't have internet connection, the application loads. And it kind of gives you the native experience of the thing. And of course, there's the Angular Universal, which deals with how do I pre-render the page on a server before the browser, for slow connections and also for search engine optimization. We'll talk about that in a bit as well. On top of that, we've added some cool tools. So we have CLI, which we'll talk. CLI allows you to generate projects and maintain your projects and help you with testing and just basically all the machinery you have to do to get your code out, not the actual code itself. So we'll help with that. We have language services. This is super cool. This is a plugin for IDEs, which runs in the background in your process, collects type information, and then you can use the type information inside of your templates. So that if you're inside a template and you start typing food dot, it will autocomplete and say, well, the possibilities at this point are the following, and it lists every single thing that you can do. And finally, there's Augury, which is kind of the replacement for Batarang, which is a plugin to Chrome, which allows you to kind of explore what's going on. And we'll look into all of these things more in depth. We have ng upgrade, which allows you to mix and match Angular 1 and Angular 2 on the same page. So that provides you a good upgrade story. And of course, we have router, animation work, and internationalization. All of these things basically come out of the box for you. So as you can see, this is not a kind of a one-trick pony that does one thing specifically. We really wanted to look at the holistic thing and solve all the problems associated with web development together for you under one roof, so that you don't have to go shop around and figure out how to integrate all the pieces together. We're trying to be not very opinionated, but we are trying to solve all of the possible ways, all the possible things that common applications have to solve. Now, all of these things are in a pluggable form, so that if you don't like our way of doing it, you can certainly replace it with something else. But the fact that there is a starting point, I think, is very important for productivity of the developers. We are in Angular 2 RC release candidate, which means we're pretty close to final. There's a few more things we're working on with the offline compiler, which I'm going to talk about, and we'll get there. So what do we focus on? I think the thing to really know is that one is you want to have a framework that is performant, but that's not itself important. It's also important that the developers are productive, right? You need both parts of these particular thing. And you want to make sure that it's versatile so that you can use it not just on desktop, but also mobile and all the other platforms we have. So let's look at performance. One of the things that we really wanted to make is that we can be small and fast under all scenarios. And I mean, that's kind of what every framework claims to do. And they're all claiming that they're fastest, etc. And so instead of talking about or showing numbers, I'm going to talk to you about like how we achieve this, so that you can look at our approach and you can kind of understand that at the fundamental level there is a unique approach that we have here. So before we actually talk about this, I just want to compare to Angular 1x. So what we've done is we made render about 2.5 times faster. And then re-rendering through this thing called view caching, we made about 4.2 times faster. But to go even faster, we were actually somewhere around March, we were actually able to replace the compiler completely with a new, better implementation, which actually gets 5 times faster throughout the board. And the way we do this is we do it through a lot of code generation. So normally what happens, you take your HTML template, and the HTML template gets shipped to the browser, and then the Angular like kind of munges on it inside of the browser and renders the stuff. What we've tried to do is we actually created a real compiler pipeline where we take the HTML, we'll build up the ASTs, we run it through optimizers, and then we have backends that can write the optimized code into different forms. We can write it out into TypeScript, we can write it into ES5, ES6. We can write it into even other things, like for example, we're thinking about writing it out to Java so that we can run it on Java servers as well. So really there is, and certainly we can also write it to Dart. So we have these choices of languages that we have, and we have a real pipeline where we can, just like compilers where they optimize your code, we can do the same exact trick over here. And our hope is that over time we're going to get smarter about the way we optimize the code and get there. And to be able to do this, one of the key things is that Angular 2 HTML templates have to be statically analyzable. That's the big thing that changed between Angular 1 and Angular 2. And it's the reason why many of the changes were driven. Like, we didn't just change this because we wanted to change. We actually had a specific purpose from the very beginning that we were driving after. And so with this offline compiler, we get this performance optimization. Now let me show you kind of how we get the size down, and we'll talk about how this works. The Angular 2 payload is about 170K, so it's much bigger than Angular 1. But when we use offline compilation, the applications that we generate are on the order of 22K. And this is kind of the first order of the first time we tried this, we got about 22K. We have a lot of ideas on how to get this number even down, even further. And our audacious goal is to get it down to about 10 kilobytes. So how does this work? So in Angular 1, you get XHR. The XHR, fetches your template. It goes into the parser, which is a C code. and then it generates a DOM, and then a DOM is handed over to Angular 1, which then does and performs its template computation to make sure that it's easy to clone the template, and then inserts the template as it's needed. So basically built a lot of internal data structures. And it turns out that the code it generates is something called a polymorphic code. And the polymorphic code is a fancy way of saying that every time you come to a function call, you actually don't know where you're going to end up. It's only at runtime when you actually look at this particular function reference can you actually tell where you're going to be. And this is going to make sense because at the time of compilation, Angular cannot possibly know anything about your application. So the code we generate is very polymorphic. And it turns out that browsers and VMs are not very good at executing polymorphic code, and the performance suffers. So one of the biggest things that you could do to make the code go faster is generate monomorphic code. And so this is how we do it in Angular 2. What we do is we move the whole pipeline of taking a template, parsing it, generating ASTs, and spitting out source code into an offline step. So this happens not in the browser as it does in Angular 1, but really as a compile step before it even gets shipped to the browser. And the code we generate is code specific to your application so that we get to remove all this polymorphic code that existed before, and we get to also in the process kind of remove the whole framework. It turns out that once we generate all the source code, the framework is not necessary. So we get two things out of this. First, we get much smaller size, and second we get is we get code that is specifically tailored for your application, and so it's monomorphic. Monomorphic is just a fancy way of saying that every time the browser, the VM comes across a method call, it will end up in the same exact destination. And VMs love that because they can inline the code, they can do all kinds of tricks to make it execute super fast. And so you get this boost. And obviously, if you generate code and it's not dependent on most of the framework, like the parser, the HTML parser, the directive parser, the compiler, etc. If all those things are not present at runtime, the startup for your application is significantly faster because there's a lot less code for the VM to parse and evaluate and execute, right? So it's a kind of a win on both sides. So what we do is you offline compile the code. The next step we do is ES6 has all these import statements, which are pretty cool, but it turns out that they add overhead. They add overhead both in size and also in evaluation code. So we use a tool such as a rollup, which inlines all of these import statements into one big file. Basically, it's like a very fancy concatenation of your source code. And it inlines them in the correct order, in which the imports happen. If there's collisions, it renames it. It does a lot of magical things. And then it generates one big file. And the next thing it does is it starts at the main, and it only keeps the functions it can reach from the main. So if you don't call a particular feature of Angular framework from your code base, that particular feature doesn't get included inside of the final source code. And so once the tree shaker kind of goes through it, we have minification process. So let me give you an example of the kind of code this thing generates. So we look at a template. Imagine you have a template such as this, which says hello name. What we generate is a hello world factory, which we have a component factory. And one of the first thing we do is we generate codes in the constructor that actually creates elements, create text nodes, etc. Turns out this is the fast. We benchmark a lot of different ways of generating code. It turns out this is the most efficient ways today in a browser to generate DOM. The nice thing about this is that you automatically get references. You get reference E0, E1, and E2, as you can see on the left-hand side. And then what we can do is we can generate the change detection system. And in the change detection system, we simply say, we remember the last value, and we simply compare, is the current value not equal to last value, right? And if it's not equal, then we directly go to the element 0 and we set the text name, the interpolation in there. And this is what we call obviously fast, because you look at this code and you go like, I don't know what else I could remove. Actually, there is one thing we can remove, and this is one of the things that we're thinking about, is we currently have renderers so that we're independent of the DOM. But because we have offline compilation, we have ASTs, and we have all this pipeline for manipulating it, what we can do is we can actually generate a different source code for different targets. So for a browser, we can actually directly inline document.createElement instead of render.createElement, which would further increase the speed. So it turns out at runtime, the VM can inline these things, but at the beginning, the VM doesn't know what to inline, so it kind of keeps statistics. And so at the very, very startup, having this trampoline adds a little bit of cost. So we can remove that cost by just generating the code directly. So we could generate a different output for a browser, a different output for a web worker, a different output for a server-side compilation for your application. Okay, so this is what kind of it looks like and why it's fast. And the nice thing you get out of it is that if there is an exception in there, it actually points directly to a specific line number. So we can generate line numbers, as you can see. We can say app.html line 1, column 5. And it shows that it was actually calling the get property on a property called name, right? If I go back to the template, that's what it is. You know, line 1, 5, we're reading a name property. The name property, for whatever reason, decided to throw an exception, and you can directly see inside of your source code where that's coming from. So all those magical stack traces that you used to get with AngularJS 1, where you couldn't figure out what's going on, a thing of the past. Okay, so we talk about offline compilation. So inlining the modules. So what happens here is files are broken up into different, your application is breaking up into different modules. We have core, common, compiler. And they're all bundled together through import system. And the import system is really the future. Like, it's part of ES6 standard. So it is what you would expect. But it turns out that the import system is not free. There is some cost, both in terms of the bytes and the wire you have to send across, and also in a form of evaluation of what has to happen. So what we have is a rollup can do a rewriting of the thing where it essentially concatenates the file together. And by doing that, it actually, depending on how big the file is, so typically, you know, good practice says that your file should be small and you should do lots of small imports, right? But that's exactly the thing that's going to blow up your application. So with rollup and this inlining trick, you don't get penalized for the fact of doing the right thing, of breaking your app into lots of small files. Next thing, again, what we talked about is tree shaking, which is we simply go and we find that the compiler is actually not used in the final product because the compiler is not referenced because we offline compiled, and as a result, we don't include it. But we'd also go further and we don't actually include certain parts of these inside of here as well. And there are plans to generate even more stuff, and so even more stuff could eventually be tree shaken away. And finally, we run a minimize where we take the source code and we munge it through something like uglify or closure. And this is what you kind of can see. So in a normal UMD bundling system where you would use the imports, you would go from 12 HTTP requests down to, if you use CommonJS, which is where it's the normal bundling, where you preserve the imports, you would get about 4. But if you go all the way down to inlining, tree shaking, etc., you get 2 XHR requests. And those 2 XHR requests is really the zone polyfill and then your application. So this comes down to pretty small. This shows the different sizes of your application and how they get shrunken over time. So you can see that by doing these kinds of tricks, we can really go down from several hundred kilobytes down to about 50 kilobytes, which again, is going to come down even further over time. And the biggest winner is the load time. You know, from going from a half a second down to about 130 milliseconds for bootstrapping an application. And so you can imagine how this has a significant impact on a mobile device, which is constrained in terms of bandwidth, in terms of getting the data, number of requests, how fast it can bootstrap, how much memory it consumes, because it's not just fewer lines, right? All of this translates to less memory consumption as well. And so we are currently now about 45K for Hello World application, and as I said, our goal is to do it even better, and we have planned in the future to shrink it even more, and I think at the very least we should get to 10 kilobytes for a Hello World, maybe even better with these things. So our boss said he will get us a cake if we get there, so we'll see. Now, we're always thinking about how else we can make this smaller. So the next thing we wanted to do is making sure that if you have a humongous app, that you only load the source code that you actually need for rendering that particular page. So we do code splitting. The code splitting goes through routing. We take your app, chunk it up into pieces by the route, and then we only, if you navigate to a particular URL, you only get that chunk of the source code that is actually pertinent to that particular URL. You navigate to a different URL, you get the next chunk, and so on. As you navigate to different places, you get more and more stuff. So that's how we make it small and fast. And we actually have these benchmarks. So we have these benchmarks where we build applications using hand-coded JavaScript. In other words, we do everything, every trick in the book that we can think of, and we hand code the same exact application as we build in Angular 2. And we compare the performance, and the idea is that we want to really compare ourselves not to against other frameworks out there, but really against what is theoretically possible. And currently we're about 40% of theoretical possible limits. So we have some work to do, but really think we can get to within about 10-20%, somewhere in there. Okay, so the next thing is Angular Universal. I'm sure everybody's wondering, how do you pre-render your page for SEO, more importantly, and also for just being able to get a faster startup, especially on mobile. So in universal rendering, you get a request. The application executes on a server. Maybe it's pre-cached. What's sent back to the client is HTML and CSS, which can be rendered immediately, progressively, from the top to bottom. And then afterwards, we send over the JavaScript, which is your application itself. And because of that, we can render essentially instantaneously. And by the time the user figures out what exactly they want to click on, we can get the JavaScript in there as well and bootstrap it and run it. One thing we do is at the very beginning, we send a little tiny snippet of code that captures all of the events and then replays them back when the application bootstraps. So if the user is really quick and then clicks on a button before the framework bootstraps, we record that information. When the framework actually bootstraps, we play it back and execute it. So you can do that today. This runs on Node.js, ASP.NET, and we're thinking about adding more support in the future. Again, this is through this code generation where we can do this stuff. The other next thing is we have these things, web workers. All modern browsers have multiple cores, but you can't really get to them because all web browsers essentially are multi-threaded by design. And so we'd like to move it to a web worker. Now, web worker gives you a whole new thread, but there is these constraints like you can't access the DOM and a bunch of other things. So because we have a custom renderer, what we can do is we can render into a serializable form of the Angular. And so we can actually run the Angular and your application in the web worker and just send commands over to the other side to render the DOM in itself. Now, the channel over here is asynchronous. So if you squint, you realize there's actually no reason why this actually has to run on the web worker. It could run on a server or anywhere else for that matter that has a VM with a V8 and a connection. So we can do basically serialize. We can make this communication channel over a serializable channel. So you bootstrap a little kind of a small version of the DOM renderer on the DOM side, which includes animations and interactions with the animations. And then the application runs on this side. And then we can not just do the DOM updates, but we can actually choreograph the animations information as well. So all the fancy things like a new item is being inserted into the row, you want to make space for it and then animate it and fade it in. We can do all kinds of things like that. Okay, so let's talk about productivity. So we have a tool called Augury. This is done by the community. Augury is this tool that you install inside of your web browser. So imagine you have an application such as, this is a kitchen sink of components. What you can do is you can open up the Chrome DevTools and you can see there's a new tab in there called Augury. And that allows you to go and explore the application structure. For those of you who are familiar with Batarang, it's kind of like Batarang on steroids. You can see all the components. You can see how they're nested, what their properties are. You can click on them, see what their input outputs are, event sizes, and anything else you can possibly think of in here is available here for you to explore. The other thing we can do is we can actually show you the dependency injection tree. We can see who's getting what components from where and how they're being built up. So if you're wondering like why I got this particular instance, you can kind of explore it in here. And not just a dependency injection tree and a component tree, but also a router tree. This shows you how this application will route into subroutes and what things get lazy loaded at what time. So the other thing we wanted to do is we wanted to make it simpler. And in Angular 1, about 43 directives turns out are not needed if you introduce this concept of a property binding and an event binding. So last year I did a talk in ngconf about like why exactly we have this syntax. It was very controversial. But the nice thing about it, some of you might remember, I guess if you're laughing, the nice thing about this is that it removes a knowledge of significant number of directives from Angular 1. Things like binding to hidden or show, or binding to events, clicking, etc., can all be expressed in this succinct syntax. And the nice thing about this syntax is that it actually works not just with DOM, but with anything. It works with web components, and it also works, such as a Polymer, but it also works with non-DOM renderers, such as React Native or NativeScript, which we'll talk about in a little bit later. So the thing is, you can build apps as an individual, but really, if you're on a big team, it's really where it counts, and you want to make sure that as a big team you can be productive. And so at Google, we have large teams. For example, the new version of the Google AdSense, where you configure how ads get displayed to the users, is being rewritten using Angular. And those are literally hundreds of developers working on this particular thing. So you want to make sure that these hundreds of developers can talk a common language, can understand each other, not step on each other's feet. And so a lot of design decisions that were placed in Angular 2 are with this in mind. So you might think that certain things are kind of, why did we do it this particular way? Making sure that you can scale to large teams is one of them. And from the get-go, we have a style guide saying these are the best practices, this is what you should be following, and these are something that you shouldn't be doing. Not only do we have a style guide, but it turns out somebody in the open source community actually wrote a linter that verifies that the style guide is followed. So you can have a set of warnings that automatically uncheck and will tell you you did something that the style guide says is not a best practice. And finally, so this is the code analyzer, which we just talked about, which does this analyzation. And the other thing is that we run on top of TypeScript before we get to the CLI. We run on top of TypeScript, and TypeScript, I think, is very cool, mainly because all JavaScript is actually valid TypeScript. This is an important thing to realize. You can take regular JavaScript, and it is TypeScript. And what you can do with the regular JavaScript, including ES6, ES5, is you can extend it with additional type information, which is completely optional. So you can start with your regular JavaScript code that you have. You can just rename it from .js to .ts, and TypeScript compiler will run across it. And then as time goes on, you can say, it'd be really nice if I knew what the type of this thing was. And so you can start adding types over time, more and more and more, and you can get more things. Turns out even if you don't add any sort of types at all, if you're writing pure vanilla ES5 code, TypeScript is already helpful because it can analyze your code and you can statically infer types in many locations. And of course, because the Angular framework itself is typed, it will autocomplete on the Angular framework as well. So at the very minimum, you can actually get completion from calling into the framework. So that's super cool. Anyways, let's talk about CLI. So CLI is a tool where you can very quickly get a Hello World application going. You install the tool, as you can see. You say ng new my dream application, and it will generate all of the scaffolding that you need. The index packages, set up the testing story, the end-to-end testing story, the routes, everything you can think of, linting, automatic code formatting, everything you can think of that a good project should have gets automatically set up with this thing. And finally, you just type ng serve, and it will get a server going, will compile your TypeScript code on the fly, serve it, auto-refresh it. So it provides a beautiful experience to the developer from day one. And you don't have to figure any of that stuff out. It's just available for you from day one for you. So here's what we do. As you can see, we create a project, we generate components, we have a development server for you, we generate routes, linting, formatting, scaffolding, run the tests, pre-process CSS, deploy, and doing the build. So the whole 9 yards of managing a project is kind of set up for you automatically. This kind of just shows all the things you don't have to do. And so basically all these steps that just got replaced by ng creating. Okay, let's talk about versatility. So one of the things we wanted to make sure is that when you learn a new skill, such as Angular 2, it's available on not just a browser, but you could use the same exact skill for mobile or for desktop. So let's talk about those. First, for the mobile, we have the mobile Angular I/O, which is a set of blueprints that automatically sets your environment up so that we can do these progressive web apps where you navigate to a page, we can install an icon on your mobile device that sets up automatic caching of the content so that even if you don't have internet connection or if you have slow connection, the thing is available offline and you can execute the application and run it. So basically all of the best practices that you need for building a mobile applications have been distilled into here and are automatically available for you. So, okay. So here's the list of things. We set up web workers, we set up caches for you, we figure out how to do push notifications, offline things, universal pre-rendering, right? All of these things are figured out for you in that particular package. But just having the application is not enough. You probably want to have some kind of a UI. So the most common one people choose is Ionic. Ionic takes basically HTML and through a clever set of divs and spans, it builds a UI that looks native, but it's actually HTML. The next option you can do is NativeScript. NativeScript does a slightly different approach where it actually generates, it bridges the native API, the native C API, and makes them available inside of JavaScript. And then it goes a step further and it wraps those APIs to make them consistent on all the platforms. So saying make a new button on iOS will look like an iOS button, making a new button in Android will look like an Android button, and same thing for Windows Phone. So the NativeScript is a really cool experience because you're generating a truly native application that uses native components underneath. These are not web views. There's actually no HTML involved in this particular case. That have a completely native look and feel, but at the same time you get to do all the things you know from Angular 2, including animations all throughout Angular 2, in Angular 2, and it's consistent across all the different platforms. And final one is React Native. So React Native does a similar thing as NativeScript, but it's a little more low level than NativeScript. It doesn't provide, it's actually a different API for each platform. So there's a different way in iOS to make a button than it is in Android. But the advantage is it's a little more low level, so you have a little more power on it. And again, these two choices, this take advantage of the fact that we can render to non-DOM targets. And we have custom renderers that actually render into native components. And then in the desktop, we have this popular thing called Electron. I'm sure you guys heard of it. But in the past, when you wanted to build it, you basically got two instances. You got a Node instance inside of the Electron, and you got a Chrome instance. And inside of the Chrome instance, you could run Angular, but inside of Chrome instance, you cannot access disk operations, right? There's no I/O available. So you essentially have to pretend to make a XHR call into the Node side, and in the Node side you can do file access, etc. And so you live in this weird world where you kind of have to go back and forth. So, but Angular knows how to do this trick, which is this is the same thing as web workers, right? So we know how to actually run your application in Node.js, where you have full access to all of the API, including file I/O and everything else you can possibly imagine. And we automatically do serialization between the two for you, so you don't have to do it. So we greatly simplify the way you would develop a Electron application. It's faster. It has all the platform APIs, and you get to access things like hardware, like location, geolocation, etc. We provide Material 2 is part of Angular. So if you're familiar with the Google Material Design look and feel, all of that stuff is being rebuilt inside of Angular 2, and this is available today. And there's actually a lot of third parties who are making their widgets available as well. We have Vigimo and a few others who are doing it as well. Now, the next cool thing is we have a bunch of developers. We have Angular Advocacy Group. This is new for Angular 2. And these guys and gals are responsible for making sure to reach out to you guys and find out what is working, what is not, kind of feedback information to us and make sure we have a better feel of what's going on in the community. So I'm sure you guys are looking forward to having interactions with them. And finally, we're big fans of open source. We do all of our development in open source, and we love our community, and we have lots of great developers that are community, pull requests, etc. to our code base. We appreciate that, and we want to make sure that stays. Turns out there are already books being written for Angular 2. Somebody's an author over here. There you go. So, and there's going to be a raffle of a book today. So I think it's super excited that we're not even in the final, and already there is something like 8 books written, and who knows how many more are actually being written for it. There are trainings by a lot of different companies, including this one. A lot of third-party libraries are being written for this thing as well. So we have a lot of IDE support. So there's a beautiful ecosystem of things that you want. So this community is really healthy and thriving. So let me show you a couple of examples. So for example, Kiva, they built an application, as you can see over here, and this application looks native, but it's actually built using Angular 2 and Ionic. So this is actually a web view, which is pretending to be native. It has the kind of a look and feel of an iPhone app, but it's actually a browser application. And we were able to get, the Kiva was able to get 60 frames per second, native transitions, basically all of the things that you would expect from the development cycle, especially the auto refresh thing, which is pretty cool, which you cannot really do with the compiled stuff. You can get in while developing this application, and it goes into regular App Store as a regular app. So that's one approach. Another approach is NativeScript, as I talked earlier. So what NativeScript does is it wraps native APIs and makes them available for you, and they have a rich set of things like widgets, graphs, etc. And NativeScript 2 is built on top of Angular 2. So this application here, you would build in the following way. Like you can see, like you have CSS, you have directives, just everything you know about Angular 2 and how Angular 2 is written is done in the same exact way here. But notice they decided to show off that this is truly native application by if you click on it, it kind of explodes in a strange way, which is something that you can't really do in HTML very easily. So this kind of shows up how you can build a truly native applications, and this I guess runs on Android, and so it has completely native Android look and feel to it without any kind of effort. Turns out what you write inside of the app.html is you write XML, and instead of using divs and spans, you would write whatever the vocabulary of the native script is for building an app. So that's pretty cool. Same experience, but you can do NativeScript. Another example is Fidelity. Fidelity actually, using NativeScript, built their application. It's actually already available in App Store. They're kind of just showing off all the things they can do with it. But it's totally native, even though it's written using JavaScript. Another example is Lucid Charts. So these guys were one of the first ones on the web to allow you to build this really complicated diagrams. Let me just kind of show you the video of what it looks like. No, maybe not. Okay, never mind. The cool thing is, when they rewrote the application in Angular 2, they got a drop in number of lines of code, but more importantly, they got a significant drop in number of DOM elements. It turns out that having a framework deal with all the DOM is actually more efficient than you trying to do it yourself. And so they got about a third of number of active DOM elements at any one time, which means the application feels faster for the same amount of resources. And so a Capital One is another one that has used Angular 1, and they had a huge problem in the past where they couldn't do SEO. They used originally Angular 1. And obviously the problem is that they had to kind of have their own pipeline for how do you make sure that when a crawler goes across it doesn't get to see title description, right, in here. Because then if you actually navigate to search result, you actually will see double curlies inside of it. So they had a complicated set of internal homegrown machinery to do this. The biggest problem was that their pipeline wasn't able, it was essentially a different things, wasn't able to take care of directives that they've already written. They had to re-implement a couple of things, etc. And so with Angular 2 and Universal, this kind of gets taken care of automatically, right? Because we can execute the application on a server and just send over the source code, already rendered HTML and CSS. And what you end up doing is that you still have to do all the same amount of work, but you get to push the painting from way down end to the beginning, and so the user can interact with the application much, much faster. And the bonus thing over there, at least for Capital One, was that they got to use TypeScript. And it turns out if you have large teams working on stuff, types really matter because type give names to things. And so when somebody else comes over and wants to talk about something, now you have names to things. And also it gives tooling so that you can rename things, you can refactor things, move things around, and you can be reasonably confident that all these operations are safe. So, it solves a lot of important problems for people. So I think that's it. Did anybody keep time? I'm just kind of curious, how much was it? Was fast? Okay, I should talk slower. I'm happy to entertain questions if anybody has questions. Okay. If anybody has questions, it's recorded, so we probably should get a mic.
Yeah. Someone has any question? Hi. So when can we expect the new reactive form directives to hit gold?
Your reactive style directives?
Yeah.
Those are available already. So when you're building a component, you get to choose whether you want to do full change detection or whether you want to do push. When you want to do push change detection, then you can essentially get yourself marked as dirty only when inputs have changed. And if you couple that with the Flux architecture, such as we have NGRX store, then you can have kind of the Flux style of building applications. So this is something that you opt into. I believe our material design as of right now has not opted into it, but it is very high on our priority list. So that material components that you use within your application, which usually actually account for a large chunk of your change detection time, can actually not be counted for it. So this is something so you can do it today. It's going to be available in material design soon.
Good. And what about the new router?
So I'm sorry?
What about the new router?
What about the new router? What about it? It's new. Yes, and we hope it's the last one. I mean, it turns out routing is super hard. We have learned a lot of stuff. We've been, talking to the community, and we got a lot of feedback from the community. And so we just kept iterating until we got it right. And the feedback we've been getting lately is that it is actually solving the needs that they need. So.
Well, my question is about, I've been working for a while with the Angular 2 mobile toolkit and with Universal. And I saw that in Universal, you can see the SEO of the full application, but on mobile toolkit, you cannot. You can only see like the first page.
You're saying the mobile toolkit?
Well, the mobile Angular 2.
I believe mobile also works with Universal, so it should be rendered. And actually, they have directives where they can specify what things to show to the user.
Yeah, the shell renderer.
Yeah.
Are you sure? Yeah.
I don't know. If it's not, it might be a bug to be fixed, but I think the goal is to get there. So
okay.
Those things should work. There is no technical reasons why they shouldn't be able to work that way.
So at the end, if the SEO didn't work for, well, at the end it will work the SEO for the full application, right?
That's right. So I mean, this works today. I mean, as you can see, like for example, Capital One already has this deployed in production, where if you navigate to the page even regardless if it's a crawler or a browser, the Capital One will serve up the rendered code first, and then only later send over the JavaScript. And the crawler obviously ignores the JavaScript, but like you'll see the rendered code in there.
So if I were to make an application right now, the best idea would be to make it already for the mobile progressive web app,
Yes.
more than universal only.
Well, they're not. They're two different things, right? Progressive web app really talks about how do you make it so that it's cacheable and available on a mobile device. So if you're not targeting mobile devices and you're not targeting the offline mode, it probably doesn't have much value for you. But mobile does use universal underneath, so those are two separate things.
Okay. So you would recommend doing for the progressive web apps?
If you're building a mobile app, then do progressive web app.
Yeah.
If it's a desktop app, then you probably just want to do universal.
Okay, thank you.
Any questions?
What tools do you recommend us to use to develop Angular 2 apps with TypeScript, especially considering debugging?
So, as I said, I'm a big fan of TypeScript, and specifically because TypeScript is not a new language. You know, they're not coming in and saying, "Oh, JavaScript is broken. Let me fix it by inventing a new set of differently broken idioms." Right? Instead, what they're saying is like, "Look, JavaScript is what it is. We're just going to add one feature that we would like to have, and specifically that feature is types." And you can think of a TypeScript compiler. It does checking to make sure the types you declared are correct. But for the most part, all it does is it strips out anything after the colon. So if it comes across colon, whatever, it just strips it out. And this is the important distinction between TypeScript and all the other languages that are transpiled to JavaScript, which is that the source code that you get back out of TypeScript is very recognizable because it is the exact same source code, line number for line number, comment for comment, that you've put in on the other side. It just has the type information stripped out. Right? This is not the case for some other languages where they have to do semantic matching, where a plus operator in JavaScript has a different meaning than a plus operator in this other language. And so now they can't just call plus, they have to do all this complicated dispatch mechanism to match the semantics of the two, right? So it's important that you look at it that way. The other thing to realize is that TypeScript has a beautiful escape hatch. If one day you decide that TypeScript is not for you, you just take the generated output from TypeScript and you make that your new source code because it has all of the comments, all of the spacing, all of the indentation, all the code exactly as you put it on the other side.
Any question more? No?
That was easy.
Thank you for the presentation. Can you explain a bit what improvements do you have in Angular 2 for testing?
What?
The improvements of testing in
what
Angular
improvements
2?
do we have for Angular 2 testing? It's a good question. You know, for the most part, I think the philosophy of the testing is the same. So I'm not sure there's huge differences. We have protractor in Angular 1, just like we have in Angular 2. We have lots of unit testing. Dependency injection is more powerful, so there's some improvements in that. One of the cool things we can do in Angular 2 is because of the zones, we can auto-detect an asynchronous test, and we know exactly how long to wait before the test is completed. We can, if you declare that the test is synchronous and you attempt to do an asynchronous operation inside of the test, we will flag the test and fail it for you. So we have some pretty cool things we can do around sync and async, and specifically about turning async code into sync for the purposes of the test. So there's some cool things in there.
Hi. You were talking before about the mining of the JSs, and I tried that in Angular CLI right this afternoon, and I did not get that to work. Is it already
You didn't get the Angular CLI to work?
No, the Angular CLI yet, but the inline version of the JS is all compiled in one file.
Oh, yes. That's the thing, that the offline compilations is still stuff that we're polishing. If you know how to walk the minefield, you can get it to work today. But this is the thing that's keeping us from shipping the final. So we are improving many areas of this location to make this possible. So that's coming.
Okay, thanks.
More than a technical question, it's an advice for me and to record to my bosses. How we can ship entire team to embrace Angular 2? Your advice to us to migrate our applications to tell everybody, okay, let's move.
So you want to move an existing application from Angular 1 to Angular 2?
And try to, because we work with some large teams, need to, of course, be on this process of learning while
Right.
you're at.
So first of all, just to be clear, we still support Angular 1, and so you don't necessarily have to move, although of course we would like you to move. You can certainly just continue being on Angular 1 and enjoying all of the stability that you get with Angular 1. How to convince somebody to move? There's arguments to be made for productivity, arguments to be made in better code size, better maintainability of the code base. So those are the things that I would have a discussion over. On the end of the day, to a large degree, it's a personal preference that you and your team have to make. But I think what I try to kind of convey to you is that Angular 2 kind of has grown up. It's not a framework that does, data binding to the web application. It's a whole platform where you really are trying to address every single aspect of the life cycle of your application, not just the framework bit. And I think this is really the differentiator between Angular and just about any other framework, because you really at that point are not comparing apples to apples. Because there really isn't anything else out there that is this thing that looks at the holistic view of everything and how to make it work. So having kind of the end-to-end thing, I think, is the big selling point that I would have a discussion about in the company.
Thank you. Just to say that after listening all the talk, it's really difficult to not start thinking of moving to Angular 2. I mean,
good. I succeeded.
It's really difficult. My question was regarding the slide when you explaining how the Angular core can run in a web worker. Mm-hmm. Okay, and you mentioned that technically there is no reason why we can move that part also to the server, mm-hmm. and just reach the let's say the browser to do basically updates on the DOM. Mm-hmm. Somehow I feel that will be slow. I don't know.
Well, yes, we wouldn't recommend, because scalability-wise, like if you have 10,000 people connecting to you, you need to have 10,000 instances of Node running. Like it's doesn't scale from that point of view. But I think it more kind of shows the flexibility of what is possible. It actually is very useful for debugging, because you can now run Angular 2 inside of the Node.js in the same exact instance that actually runs your backend, which means now you can place breakpoints across between server and the UI code, which is pretty cool, right? Because normally, like, you have one environment for putting a breakpoint inside of the front-end code and another environment for inside of the server code, and if you want to kind of interact between them, it's just a headache. So with this way, it's a little bit more work to kind of set up your app so that it can be bootstrapped inside of a server, but what you get out of it is that you can do this. The next thing you can get out of it is, because the rendering is write only, we can split it, and we can actually interact with a single app but render it on every single browser. So we can render it on a Chrome, Firefox, IE, but also on maybe a mobile version of your browser as well. And then if you click on one particular item inside of any of the browsers, then all of the UIs update synchronously between all the different browsers. So you can kind of verify very quickly, like, does this app make sense in all the different browsers together? So there are some use cases such as that, but you're correct that for production, this is not what I would do.
Yeah. When you say that, I was thinking that maybe in a scenario like how native script works, where there is a V8 running in the mobile, maybe you can have the Angular core running in a native thread, and then just refreshing, in that case, not the DOM, but the UI, only when there are events that need to change the UI. So then you have the UI and the core running into different native threads, and that could be maybe a scenario of that case.
Yes, and that's exactly what the Electron does, right? Electron allows you to run your application inside of the Node.js so that you can have direct access to the I/O, and it will automatically marshal it across the wire to the Chrome instance so that it can do rendering. And you could theoretically replace the renderer, and instead of having a Chrome renderer, you could have a native renderer on, on a Mac OS. Nobody has done it yet, but it would be theoretically possible.
Okay, thank you.
And if everyone talks so good about Webpack, why CLI wasn't made on Webpack?
So it's funny you bring that up because we are actually discussing about doing it on Webpack. It turns out CLI originally was a Ember CLI. We worked with the Ember community to kind of customize it for Angular. And inside of it, they used System, and so we kind of inherited it. But we kind of realized that we would like to go to Webpack as well. So there's internal discussions being made about how we could integrate Webpack as well. So the one of the reasons why it is kind of hard to kind of get the packaging right of Angular is because we want to make sure that that works across many different scenarios, everything from rollup to Webpack to System.js to UMD. And so we want to make sure that we have it working in a way where whatever you choose, it really should be a choice of your choice. It works even though we have some personal opinions, what we think is the most common case of setting it up. So it's in the works. Is the mic on? No, is the microphone on?
Hello?
Yeah.
Oh, okay. So my question was, not that you mentioned, I think it's the buffer.
Okay, I'll try to repeat the question.
The question was, now that he mentioned Webpack, I was thinking before when you explained the automatic lazy loading, how that works with packaging systems that unify everything together. Is there some kind of best practice that we should use in order to get benefit of the automatic lazy loading?
Right. So what Angular 2 allows is all the machinery around the framework to enable lazy loading. The Angular itself has no opinions about how you lazy load code. So I believe Webpack has a way of splitting things up. I know Clojure has a way of doing it. So what we just are mainly focusing is making sure that once the code is split up, we can lazy load it. Probably after final, we're going to focus more on making sure that the pipeline for splitting it up is more clean. But the primary focus right now is to be able to run offline compiler and and be able to package it up as a single application for now. But that's going to come soon after.